All right, folks, this is going to be day 2 for our unit circle. Today's going to be a little bit more of the practice on how do we know how to find sine and cosine tangent values, the reciprocals, by just realizing what we know about quadrant 1 and that all of those triangles are actually, in fact, the same. Just the only thing that changes as you go from one quadrant to the next are the signs, the positive and value or negative values that you have. So what we're going to talk about first here is just sort of our approach to these, like how do we figure out these different values. All right, so our process here for kind of thinking this through is you really just need to use what we call the reference angle. We've already talked about that this year. So think back what a reference angle is. So it's the distance from the terminal side to the x-axis. If we know the reference angle, then we know our quadrant 1 picture. So if we know that it's 30 degrees away or 45 or 60, we're going to be able to know that quadrant 1. If you know quadrant 1, you know all the SOHCAHTOA ratios for that quadrant. Then after you figure out the reference angle, then you just figure out which quadrant you are in for the angle that you have. So everything stays the same. It's still the same ratio, but as you go to a new quadrant, then what can change is the sign, the positive and negative. So we make that adjustment. So figure out the reference angle. That's step number 1. Step number 2, use the quadrant 1 angle then for that reference angle. So it's going to be that ratio. And then the third step is just figure out where you are. So what quadrant are you in? Then you know the sign of your ratio. So it's kind of those 3 things. All right, so that's what we're going to be practicing today to make sure that we can actually find those values. So let's talk through a couple of them first, just sort of kind of basic numbers, and then we'll check with the unit circle and make sure we're okay. The ones that aren't in a quadrant, we really just have to think about the location. So for this first one, what is cosine of negative 180? These are the kinds of special value numbers that I would expect that you'd be able to do without a calculator. So negative 180, remember negative angles just means you're going around the other direction. We'd be at that location right there. I think it's really helpful to think of the picture when you do these, to picture it or actually draw it, especially for the first few times. This ordered pair in the unit circle then would be negative 1, 0. So that ordered pair, x and y. So remember, cosine of our angles are always the x values and sine of our angles are always the y. It's alphabetical, x, y. So in this one then, our cosine value, that's the adjacent, would be your negative 1. So cosine at negative 180 would be negative 1. So don't let the negative angles throw you. Just go around the circle the other way. We still do the same thing. For the second one, tangent of 45. So 45 degrees, that's in quadrant 1. So the reference angle is actually the 45-degree reference angle. So it's our regular 45, 45, 90 triangle. When you think about tangent there, we had our unit circle. Both sine and cosine are exactly the same. You can look at your pink sheet to be able to reference this. So it's 45, 45, 90. Both sine and cosine are the same. So what that tells me is then that the ratio for tangent, opposite over adjacent, would be, as always, when it's a 45, 1, because it's the same value divided by itself. So being able to check that location, so the reference angle is 45, I know what picture I'm dealing with. Okay, let's try one kind of start to finish the whole deal. So we're going to look at a 150-degree angle. Now I want you to ask yourself those 2 questions. What quadrant are you in? So 150, where would that be? So that's quadrant 2. And then what's your reference angle? So I'm going to abbreviate a little bit here, but reference angle. So how far is 150 from the x-axis? Well, that's 30 degrees away. So if we just use the answers for what sine, cosine, tangent are for 30 degrees, the answer for 150 is going to be identical because the triangles are congruent. They're the same. It's just that because we're in quadrant 2, some things are going to be negative. What's going to be negative when you're in quadrant 2? Well, anything that you have to go left for, so the x value, so cosine would be negative, and also tangent, because tangent is y over x. Now I'm not always going to do this, and I'm hoping you don't always have to either, but I'm going to go ahead and draw the picture for 150 so we can think about what this means. So standard position angle, 150 degrees. So that means our reference angle, distance to the x-axis, is 30. So if I put a point on my terminal side of my unit circle, so I'll have my hypotenuse be 1, drop that perpendicular down to the x, back over to the origin, I have my 30, 60, 90 special right triangle. Now remember that relationship between the hypotenuse and the short leg. The short leg would be across from the 30. If the hypotenuse is 1, the short leg would be a half. It's always half of what that hypotenuse is. The other side of the triangle, the longer leg across from the 60, is always square root of 3 times the short leg. So that's square root of 3 over 2. But now look at where you are. You're in quadrant 2. You went left, which means that It has to be negative. That's the direction that you traveled. So we can draw the picture and then you can do the SOHCAHTOA ratios. That's totally fine. But just realize that when you do that, your answers are the same as what they are for 30 degrees. So if you just looked at the 30-degree triangle, you're going to get the same answers other than sign changes. All right, so let's talk about sine of 150 then. So in this triangle, that would be opposite over hypotenuse. So it's going to be 1/2. It's positive because the y's are. Instead of looking at the picture though, I could have looked at my angle for 30 degrees and I can look in that angle and I could say, okay, at 30 degrees, sine is 1/2. So it's going to be exactly the same at 150 because they have the same reference angle, the same triangle. All right, let's try cosine of 150 then. You can use the triangle, you can use the picture. Otherwise, just think, what is cosine of 30 degrees? Well, cosine of 30 is square root of 3 over 2. But because we're in quadrant 2, that means cosine has to be negative because it's the x. And if you look at your triangle, sure enough, negative square root of 3 over 2. Okay, let's try tangent of 150. Tangent is going to be that ratio y over x. Look at what tangent would be for 30 degrees. So a tangent of a 30-degree angle was square root of 3 over 3. And again, you could do the division if you need to. So it's 1/2 divided by square root of 3 over 2. But because we're in quadrant 2, it has to be negative because it's a y over an x. So the answers, when you look at the ratios, are all identical to quadrant 1. Just the only thing that changes is the sign. So if you know quadrant 1, you know everything. Now let's talk about 6 trig functions. So 6, what are the other 3? Well, those are the reciprocals. So you just have to remember which one is a reciprocal for each of these functions. So what is the reciprocal for sine called? Well, that's cosecant. So if I'm going to do the cosecant of 150, I'm just going to take the sine ratio and do the reciprocal. What's the reciprocal of cosine called? Well, that's secant. So the secant of 150 would be the reciprocal of this. Reciprocals have the same sign. So it'd be 2 over root 3, and that would be negative 2 root 3 over 3 when we rationalize. And some people start just remembering those numbers. They don't have to do all the arithmetic. All right, tangent reciprocal is called cotangent of 150. And when we flip that, it's still going to be negative. If you flip square root of 3 over 3, you get that. If you rationalize it, it would be 3 square root of 3 over 3. 3's cancel. You're left with just root 3. So again, I'm not so concerned about the green ones. I know you can find those out. What I'm much more concerned about is that you know how to find the ones in blue, the 150s. Knowing that it's 30 degrees, that the ratios are all the same, the only thing that changes are the signs on these last two, the cosine and tangent, because they're both negative. All right, let's take a look at another example. We're just going to try some more of these. I'm going to argue that this one's pretty darn similar to the last one. Let's see if you can figure out why. So I want you to find sine, cosine, and tangent of the angle 330. So our two questions to ask ourselves, quadrant and reference angle. So what quadrant is 330 in? Well, that would be quadrant 4. What's your reference angle at 330? How far away from the x-axis are you? Well, that's 30 degrees. So that's the same reference angle we had for the last one. So guess what? All of the ratios for sine, cosine, and tangent of 330 are going to be identical to the answers we just got for 150, which are identical to the answers that we would get for 30 degrees. They're all exactly the same except for the positives and negatives, the sign values, the positive and negative values. So let's see if we can just, again, I don't think you have to have the picture, but I'm going to go ahead and draw it anyway here so we can talk about what that would look like. So that's our 1. Our short leg is a half, other side is square root of 3 over 2. And because we're in quadrant 4, which one is going to be negative? X or Y? Well, in quadrant 4, y is negative, and remember y is sine, so it's going to be the negative 1/2. Okay, so how would I think these through then? So sine of 330, I would say, okay, my reference angle is 30. I know sine of 30 is a half, and then because it's 330 in quadrant 4, that makes it negative. And you can look at the picture and kind of confirm that that's what's true. Cosine of 330, so I would think in my head, what's cosine of 30? That's root 3 over 2. And because I'm in quadrant 4, cosine is positive. So it remains positive square root of 3 over 2. Tangent of 330, I would be thinking in my head, what is the tangent of 30? root 3 over 3, and then because I'm in quadrant 4, it's going to be negative. Tangent is always negative in quadrant 4. So you're thinking about the reference angle and the quadrant. That tells you the ratio, and it tells you the sign. All right, so we're going to practice a bunch of these now. We're just going to kind of zip through these and talk through what's important to know, and then we can practice. So if you want to kind of pause the video and do them one at a time and think it through, and then look at the results, that's probably a great way to do this. Okay, so cosine of 225. So first thing to think about is where is it? So 225 is in quadrant 3. And its reference angle, how far is 225 from the x-axis? It's 45 degrees away. All right, so what does that tell me? Well, quadrant 3 for cosine, cosine is x, tells me my answer is going to be negative because all x's are negative in quadrant 3. And then my reference angle is 45. And I know my ratio for cosine of 45 is always square root of 2 over 2. So I'm using my quadrant 1 reference angle triangle, so 45 degrees to give me the ratio, and then I know it's negative because it's in quadrant 3. All right, let's take a look at the next one. Negative angles really bother people, so let's think about negative 135. So I'm starting off at 0, 0, negative 135, not quite halfway around, would put you in quadrant 3 again. So I know sine is going to be negative, not because it's a negative angle, because the angle ends up terminal ray in quadrant 3, and I know sine is negative there. And then let's talk reference angle for a second. How far is 135 from 180? 45 degrees. So again, think about that quadrant 1 triangle. What is the sine of 45? Well, that's root 2 over 2 again, so I know that this is going to be negative square root of 2 over 2. It's in quadrant 3, 45-degree reference angle. All right, let's try a couple more. 315. 315 is in quadrant 4. And the reference angle, how far is 315 from 360? That would be 45 degrees again, really hitting this reference angle here. All right, so sine of 45 degrees, square root of 2 over 2, using my quadrant 1 triangle, square root of 2 over 2. And because it's in quadrant 4, sine is y, the y value, and y values are negative in quadrant 4. So it'd be negative square root of 2 over 2. All right, cosine of negative 240. So again, using that negative angle, so let's talk about where that would be. Negative 240, this is to figure out what quadrant we're in. Halfway around would be 180. We're going to go past, we're going to be up here in quadrant 2. All right, what's our reference angle? How far past 180 do you go to get to 240? That's a 60-degree reference angle. Okay, so we have quadrant 2. So for cosine, in quadrant 2, cosine is the x, so that would be negative. And then 60 degrees, what's cosine of 60? Well, cosine of 60 is a half, so this will be negative 1/2. It's the same triangle, so I'm looking at my 60 degrees in quadrant 1, cosine of 60 is a half, negative because that one's in quadrant 3. All right, let's do a couple tangent values. Tangent of 180. Again, sometimes I think it's just really helpful to look at the picture. So 180 would be over here. My coordinates over there are negative 1, 0. So that's my location. Oops, positive 180. Same location though. So over here, positive 180, it's at negative 1, 0. Tangent is the ratio y over x. The other way to think of it is it's horizontal here. So tangent, remember, is slope. So slope of a horizontal, or doing y over x. Either way, we're going to figure out that our tangent value at 180 would be 0. It's not really, again, it's still location, but you're not really in a quadrant, right? You're on an axis. So it's really thinking about, is this the horizontal or is this the vertical? So know which axis you're on. So location still, and then reference angle. So you're thinking about what it is at 0. So your reference angle for this one is 0. So it's going to have the same answer as what it is at 0 degrees, which is 0. So tangent would be 0. All right, next one, tangent of 240. So what's your reference angle? So reference angle for this one would be 60 degrees, kind of going the other order here. And what quadrant are you in if you're at 240? 240 would be quadrant 3. All right, so what do we know about tangent answers in quadrant 3? Well, if both x and y are negative, that means tangent's positive. And then we need tangent of 60. So remember, tangent is slope. So the bigger the angle, the bigger the slope. So 60 degrees is going to go with that ratio square root of 3. So if you start looking for patterns like that, maybe that'll help you remember which one is which. So the steeper the slope, the bigger the angle measurement is. So the bigger ratio would have to go with 60 as opposed to the 30, which is the one that people usually get mixed up with. All right, so that would be positive. Ooh, my goodness, square root of 3. Let's change in color. All right, last two. Let's talk about how we'd approach these two before we go on to solving for some angles. These are none of the ones that are on your pink sheet. So people struggle with this because they don't know quite what to do with it. But if you can figure out the function reciprocal, then I should be able to find out what these are. So you just really need to know, what is this CSE a reciprocal for? Well, that's a reciprocal for sine. So if I know what the value is for the ratio for sine of 60, then I should be able to figure out cosecant by just doing the reciprocal. So 60 degrees, that's your reference angle. You're in quadrant 1, so it's that regular initial triangle. What is the sine of 60? Well, that's square root of 3 over 2. So how would you find cosecant? Just do the reciprocal and then again rationalize. So 2 square root of 3 over 3. So if you know the original function, awesome, then we can find the reciprocal. That's why I don't really worry about memorizing these, like knowing them, because I can always find them. All right, so what's secant a reciprocal for? That would be cosine. So we figure out the cosine of 30 first, and that's also in quadrant 1. Reference angle is 30. That's square root of 3 over 2. Now notice these last two questions, sine of 60 had the same answer as cosine of 30. And that should make sense, hopefully, because the opposite and adjacent flip-flop. We talked about that when we made our unit circle yesterday. So those are the same values. So cosine of the one is sine of the other. So our flipped is going to be the same exact thing, 2 square root of 3 over 3. So these are the kinds of special values I need you to be able to come up with pretty quickly. I need you to be able to generate them and know what the values are without having to draw the triangle every time. I guess that's the hope. So we start memorizing and knowing what those values are. Okay, ultimately, where are we going to head with this then? Well, this is one thing, just being able to evaluate, but ultimately, we're going to want to be solving equations and graphing and doing things with these different angle measurements. So I want to talk about this, kind of going the other direction. You're going to be asked to solve some equations about tangent of what angle or cosine of what angle gives you this ratio, almost like working backwards. Now, they're going to give you a domain. So this is your angle measurement. Remember, for sine and cosine tangent, the angle measurement is your domain value. It's your input. They're asking you, for what angle measurements would these statements be true, these statements of equality. So the x here is standing for an angle, tangent of an angle, cosine of an angle. Well, is there more than one place where tangent could take on that ratio, square root of 3 over 3? For sure. So what they're asking you is, in 0 to 360, what are those x values where that could happen? So how many x values, whatever that might be. So there could be more than one location. So let's start with just one. When is tangent square root of 3 over 3? Think about your SOHCAHTOA ratios in quadrant 1. Which quadrant 1 reference angle has square root of 3 over 3 for the tangent? Well, it'd be 30 degrees. So that's one place for sure where tangent is root 3 over 3. Are there any other places? Think about your highlighting ones that you did that group together on that pink sheet. Where else do you have reference angles of 30 degrees? So we have the one in quadrant 1. Where else would it be positive? Well, quadrant 3. So what is that 30-degree reference angle number? That would be 210. So there's another place. Why couldn't you do 150 or 330? Why wouldn't those be the same? Well, both of those ratios in quadrant 2 and quadrant 4 would be negative root 3 over 3, not positive. So they have the same ratio, but the wrong sign. So the only places that we want are 30 and 210. Now, when they say 0 to 360, then I know I can stop. I know that I found all of them. But remember, any angle that's coterminal will end in that same location. So technically, there's infinitely many solutions to these equations, because every time you go around the circle, you're going to get to another place. That's why they're stopping you, so you don't have to think about more than just these first two. All right, let's try the next one. So when is cosine negative 1/2? Let's talk about negative first of all. What quadrants is cosine negative? It's the x value, remember. So that would be quadrant 2 and quadrant 3. And when, for what reference angle, is cosine 1/2? Well, that's a 60-degree reference angle. So those are still the same two pieces of information you need. So 60-degree reference angles in quadrants 2 and 3. So I need the one that's 60 degrees above the x-axis in quadrant 2 and 60 degrees below the x-axis in quadrant 3. So that would put us at 120 and 240. So it can't be in quadrants 1 or 2. It can't be the 60 or the 300 because the ratio is negative, not positive. So those signs really do matter. So really need you to practice and look at all of these different values and be able to solve for what those missing pieces are. So always be thinking, what's my quadrant 1 angle? What's my reference angle? And then once I know that, what quadrant am I in? What location? So that will tell me the positive or negative. So being able to go through and solve those. So this day 2 assignment here is to practice some of those questions like what we just did.